Video 2 of Chapter 2. Today we're going to talk about some linear transformers with some data sets. So let's say I have a very small data set of 10 numbers. And let's say these represent kind of a subset, but we'll imagine these are a population of values. And let's say all of these scores are out of 20 points. So if I did some one variable statistics, like if I put all of these numbers into a list, which if you've been watching my videos, then you would know how to put all of these into a list, maybe list 1, maybe list 2, doesn't matter which list. But if we were to do some one variable statistics on our list 1, then I get the following values. And in my calculator, I'd have to scroll down to be able to see all these, but I was able to kind of screenshot these on my computer. So what is the mean of my current set of data? Well, my mean is the X bar value right here at the very top. There's the mean, 15.65 out of 20 points. The median, if I were to scroll down, I would eventually run into MED, 15.75. Standard deviation is my SX value here. So I'm just going to go to 4 sig figs and just go up to 2.082. The range, that was max minus min. And so if I took my max of 18.5 and subtract away my minimum of 12, there is my 6.5 range. IQR was the difference of the third and first quartile. So again, 14 and 17.5 rather. If I took the difference of those, then I would get an IQR of 3.5. Now, variance is a term that I haven't used yet. And all you need to know about the variance is that it's really just the standard deviation squared. So imagine taking our 2.082 number and squaring it, and that's what the variance is. A lot of college textbooks will use variance instead of standard deviation. Now, I've got minimum and Q3, and you might wonder, why did I pick these two numbers? Just kind of go along with me for now, but the minimum is 12. Ooh, what happened there? Move you back. Why'd you scoot over? I don't know. There we go. The minimum number of our data set's 12, and Q3 is the 17.5. I just got those directly from my list over here. Okay? So now we're going to present a scenario. And personally, I always add a 1.5 point, 1.5 points to each of my students' tests. I always give them that as kind of a wiggle room, as some mulligan room, and that's just the way I flat curve all my tests. So what I could do is I could go through my list and add in 1.5 to each one, but I'm showing you a little shortcut way here. If you went over to, say, list 2, and you put your cursor up here on L2 and press enter, it will allow you to type in down here. And so what I could do is do second 1 to get L1, and I could say I want list 2 to equal list 1, but I want to add 1.5 points to all of list 1. And then when you press enter, it'll instantly add 1.5 points to all 10 of your numbers. Now, it's not hard to do it manually, add 1.5 points to each of your 10 values, but instead of 10 values, what if you had 1,000 values? You certainly don't want to go through one by one all the way up to 1,000 values and add 1.5 points. So again, you could go up to the L2. You can't be in the first entry for L2, but you got to go up to L2, press enter, and then you can say, use a different list and do something mathematically to that list. And then it'll change every value in that list and put it in your new list. So now, here are my new curved values. These all have 1.5 points added in. And if I did one variable stats on this new list, on list 2 in my case, then I get a new mean of 17.15 points. I get a new median of 17.25 points. The standard deviation, that's still the same 2.02 that we had earlier. Huh, interesting. The range, max minus min. Well, I have a new max, it's bigger, and I have a new min, and when I take the difference of that's weird. It's still 6.5. That's what it was before I curved it. IQR. Okay, well, IQR was the difference of Q1 and Q3. So my Q1 and Q3 numbers, those are different. They got 1.5 points added to them. But when I take the difference of them, man, it's so weird. It's 3.5 again. Variance. Well, earlier I said variance was just the squared standard deviations. So if I still have the same standard deviation, then I'll have the same variance, 4.335. Minimum. Well, my minimum change, it's 13.5. And my Q3 is now 19. So if I look at these numbers, some numbers changed from before I curved it, and some numbers didn't change, like these ones that are with a kind of brownish font. Bluish fonts changed, okay. Brownish fonts didn't change. These greenish ones, they changed. So here's the point. What changed and by how much? The mean and the median changed, and those were measures of center. If you think back to chapter 1, when we talked about describing distributions, SOX was a common acronym that we used, and the C of SOX stood for center. And the mean and median represented measures of center. And notice they both changed by 1.5, right? If we looked at our old mean of 15.65 and it changed to 17.15, well, how much did that change by? Well, we really just added 1.5 to our old mean to get our new mean. And the same thing's going to happen with the median. If we took our old 15.75 and added 1.5 to it, we would get the new median of 17.25. But not only did measures of center change, but really any what I will call positional value changed. So if you're talking about a specific number that could be positioned in your data set, and it's really any statistical main value, positional value, like the minimum and Q3. If I had my old minimum, my new minimum was 13.5, and what happened? It got 1.5 points added to it. Same thing happened to Q3. Old Q3 was 17.5, new Q3 is 19. How much difference is that? 1.5. Now, mean and median are positional values. Okay, so I don't want you to think that they're not positional values, but they are a special kind of positional value. They are measures of center. Now, besides minimum and Q3, could I have said something else as a positional value? Sure. Like I could have said Q1, that's a positional value. How much did it change by? 1.5. Could I have talked about max as a positional value? Sure thing, I could have. I could have talked about the 60th percentile number. It would have changed 1.5 because it is a positional value in my data set. All right, now let's talk about what did not change, and that was all those brown font values. Standard deviation, range, IQR, variance, those are all specifically measures of spread. Measures of spread. Now, from the first chapter, we really focused on standard deviation, range, IQR. Variance, I just kind of introduce in here. We're not really going to deal with variance too terribly much. And it is a type of measure of spread, but it's going to be a little bit different when it does change, which is what we'll get to here soon. So when we add values, measures of center change, mean and median change, positional values change like min and Q3, but our measures of spread did not change. Now, here's a highly technical explanation of why those things change and don't change. So measures of center and positional values are all specific values in our data set. So they all increased or shifted down our little dot plot line here by 1.5. So these red dots, that represents my 10 test scores out of 20 points. And if I add 1.5 to this 12, well, that shifted me down to 13.5, right? So I just kind of did a, I don't want to say back to back, but just kind of a two different dot plots using the same axis here. This score of 13.5 got 1.5 added to it, and now it's really at 15. This 14 got 1.5 added to it, so now it's at 15.5, and so forth and so on until the max of 18.5 got all the way up to 20. So we can see all of these positional values got 1.5 added onto it. Now, since all data values were shifted the same amount, 1.5, then all of our measures of spread stayed the same. So here's what I want to reference that with. The easiest thing to point out would be the range as one of our measures of spread. The range, that's what I have kind of highlighted in here. The range is the max minus min. Now notice our min did change and our max did change, but that difference between them does not change. So this difference, and of course it's all attached together and moving around here, but this difference, it's right here, which was what, 6.5 was our range? Really, it just gets moved down the line, 1.5 points, but the whole thing moves down. It doesn't become bigger, it just shifts down the number line. So the same thing's going to happen with our standard deviation. That idea of spread, it just moves down the line. It doesn't get any wider, it doesn't get any shorter, it just shifts down the line. Now, if we had subtracted a number, it wouldn't shift to the right, it would shift to the left. And our measures of spread would stay the same, but they would just get shifted left. All right, so now I want to introduce, instead of adding or subtracting to a data set, what if instead of 20 points, I wanted to make my test out of 40 points? Now you might say, well, then you would add 20 to everyone's score, but that wouldn't keep the same percentage for each student. So instead of adding 20 points to 20 points to get to 40 points, I'm really going to double everyone's score, and that way the percentages would all stay the same, okay? So if I took my original data set, now you are going to have numbers in list 2, but I cleared out my list 2. Now, if you wanted to put this in list 3, knock yourself out. Put it in list 3. But I'm going to re-manipulate list 2 here. So if I want to take all my list 1 numbers, again, I could go up to L2, press enter so I can type in down here, and I could say I want list 1 and multiply everything in list 1 by 2. Or I could say 2 times list 1. It really doesn't matter. Multiplication is commutative. And then once I press enter, it takes all my list 1 numbers and it doubles them all. Nice. I didn't have to do every single value that way. And so now if I do some 1 variable stats, let's jump back there, yeah. If I want to do some 1 variable stats with this new list, here's my new information. And so now if I ask the question, what changed and by how much? Well, not only did my mean double in size, my median also doubled in size, and I'm going to switch down to the bottom. Not only did Q3 double in size, and not only did my min double in size, but now look at those measures of spread that didn't change before. The old standard deviation was 2.082. Now, if I look at it on my calculator, it tells me it's 4.164. That is a 2 times difference. So this doubled, the median doubled, the mean doubled, Q3 doubled, the min doubled. Let's keep on going down the line here. The old range was 6.5, the new range is 12. How much difference is that? A doubling factor times 2. My old IQR was 3.5. What is it now? It's 7. That's a times 2 difference. And then if I look at my variance, the variance is 4.335, my old one. My new one is 17.34. Interesting. That's not doubling. That is quadrupling. So why does variance not follow the doubling pattern that everything else did? So I'll talk about that over here, down here in a bit. So I said everything changed. Our measures of center, our measures of spread, except for variance, and all of our positional values changed by a factor of 2. Everything got doubled. But there was the exception of the variance. Now, you might be wondering, why is it 4? It's because how did we get variance from standard deviation? We took our standard deviation and we squared it to get variance. So not only is standard deviation to variance a squaring factor, but if you double that, then you're going to square the doubling. So the variance changed by, and where did the 4 come from? It's because it's the doubling factor squared. Did I just hear some light bulbs turn on? I think I heard some light bulbs turned on there. So for variance, this is the one thing you got to remember in terms of multiplication. It's not just going to change by that, whatever that factor is that affects everything else, but you're going to square that difference. Okay, so everything was doubled. We're going to square our doubling, and it's really going to increase by a factor of 4 instead. Now, question of what did not change? Nothing. Every single value changed. Measures of center changed. Positional values changed. Measures of spread changed. Awesome. So the morals of the story here, if you want to transform an entire data set, like I wanted to change everyone's score, you do not have to adjust each value and then recalculate all the statistics of the new data set. So what I mean by that is this. I didn't have to take my original data set and I didn't have to come up with, well, what are the new doubled numbers? And then let me do some one variable statistics from that data set to get all these values here. I didn't have to do that. As long as I had my original data set and I had some statistics related to that data set, I could take these old numbers, and I could, in this case, double or double squared in terms of the variance here, I could double all of these numbers to get what the new statistics are without needing to know all the individual new values, right? I didn't need to know that 24 is double 12. I can take all these values and double them, or in case of the variance, double square it. So you can simply just adjust your old statistics. Your old mean can double to get your new mean. Your old median can double to get your new median, and so forth and so on. So if you have an addition transformation, this was like where I added a 1.5 to everyone's score, then the old measures of center, that was mean and median, with the addition change equals the new measures of center. So all we had to do to get our new mean and median was we just needed to add a 1.5 to our old mean and median. And our positional values, and again, for just as an example, I used the minimum and Q3. If I took my old minimum and my old Q3 and I added a 1.5 to each of them, then I knew what my new minimum and my new Q3 was going to be. However, when it came to adding values to my data set, all of my measures of spread stayed the same. There was no change. So it's going to be kind of hard initially. When you see a data set and they say, hey, you're going to curve this and add a 1.5 to everyone's score, what's the new standard deviation? Your brain is going to say, add a 1.5, add a 1.5, add a 1.5. And you're going to have to go, wait. Adding does not change measures of spread. The new standard deviation is the old standard deviation. Nice try, brain. I don't want to add a 1.5. I want to leave it the same exact value. And it will happen. Your brain will tell you, oh, you need to add this, and you don't to your measures of spread. Now, if there was some sort of multiplicative transformation, when you're multiplying or even dividing, then this is where everything changed. Your old measures of center, your old mean and median, we'll change that. In this case, we did a doubling effect times 2 effect, right? So our new mean and median were twice our old mean and median. Our positional values changed the same way. Our old minimum and our old Q3 were doubled to get our new min and our new Q3. And our measures of spread also changed by that same doubling effect, with the exception of the variance. The old variance doubled squared ended up being the new variance. So just remember variance, you're going to multiply it by whatever you're multiplying by, but you have to square that multiplication factor. So now I have a problem for you all, and this is going to be a combination of what we just talked about. It says, I have now taken the data and multiplied it by 4 and added 20 points. Calculate the new statistics by using the old statistics provided. So I want you guys to come up with what would be the mean of my new data set, what would be the median, standard deviation, range, IQR, variance, minimum, and Q3 based on the old values. Now, could you literally go take the original 10 data points for those test scores, multiply them all by 4 and add 20 to them, and just cheat, and then do one variable statistics on that on that list, on that new data set, Sure, but you're missing the point. So see if you can apply what we've done with our multiplication and addition. And you need to remember, you kind of have to remember the order of operations here. That's why I kind of specified it this way. I multiplied by 4, and then I added 20. So just go in that particular order when you're converting these old numbers to the new numbers. And we will discuss this in class tomorrow. That is all for video 2.